Hello and welcome to this video. In this video we are talking about the gates and circuits. We all know that all kind of the data like images, sounds, movies are gonna be converted and stored as binary values or bits. It means that all the computations involve changing and manipulating these bits. At hardware level, each bit is going to be represented as a voltage, and 1 is going to be represented as a plus 5 voltage, and 0 is going to be represented by 0 voltages. At hardware level, computer circuits like an adder takes input as binary values or a combination of these voltages, performing the operations on them and producing the output as a binary values too. At the hardware level, each of these circuits can represent a function. For instance, you can see a bitwise addition function that takes binary inputs A and B and perform the addition. In this course, you've been asked to build this function using Python and also design it using circuits. When we are designing a circuit, we need to think about the Boolean values, and we can represent the true Boolean value with 1 and false with 0. In Python, you've seen that using logic operators like AND, OR, and NOT, you can build a Boolean expression. In circuits, we have logical gates that performing these logical operators. We note that the AND gate is gonna be produce 1 as output if all the inputs are 1. The OR gate produce 1 as output if any of the inputs is 1. And the NOT gate is going to reverse the input. And also each of these logical gates represent Boolean functions, and therefore they can take 1 or more bits as input, and in order to represent the function of these gates we can use truth table. We can see an AND gate with X and Y as inputs and its truth table in this slide, and we can see that the output is 1 if both of X and Y are 1. We can extend this AND gate to have 4 values, but the functionality stays the same. It is true for OR gate. The output is gonna be 0 if both of X and Y are 0, and if any of these X inputs are 1, the output is gonna be 1. And we can extend these OR gates with having 4 inputs, and this is a truth table of NOT gate, which if the input is 0, the output is gonna be 1, and vice versa. So with combining these logical gates, we can build circuits. In this example, 2 X and Y's input are gonna feed into 2 NOT gates, and the result of it is gonna go to an AND gate, and the result of X and Y, and of X and Y also gonna combine to an OR gate and produce the output. So if X is 0 and Y is 1, the top AND gate, which takes the negate of Y, is gonna, the result of it is gonna be 0. And also the bottom AND gate is gonna be, the result of it is gonna be 0 because X is 0, and all of two zero values is gonna be make the output to be 0. If we change the y from 1 to 0 and feed x both x and y as 0, the bottom end still remains 0, but the top end, its value is gonna change from 0 to 1, and this makes the output to be 1. We don't look at the second or bottom AND gate because if the top AND gate is 1, one of the inputs of all gates is 1, and therefore the result is 1.